Welcome to my presentation about looking into the past couple of years in Novo Nordisk with our hype cycle of doing machine learning in our manufacturing environment. My name is Kasper Larsen. I'm a domain architect in our global IT, our global manufacturing IT group here at Novo Nordisk. I'm going to, just before I start, give you a little bit heads up that I'm not going to talk about a lot of machine learning technologies or artificial intelligence tooling. I'm going to talk about the situation we've been in order to get us where we can really take advantage of all the fancy stuff that the machine learning can do for us. First of all, just a little glance into where I come from. So the agenda for today, I'll talk about where I come from and talk a little bit about Novo Nordisk, not a lot. I'll talk about our pain and situation, where we are and how we got to where we are now. A little bit into the intelligence architecture that we have built and that we're still building, and then some focus on the structuring of our data and the organization that we built to govern it. And then at the end, a little bit of our dream. So Novo Nordisk, it's almost a 100-year-old pharmaceutical company right now, focusing on diabetes, hemophilia, growth disorders, obesity, and menopause. It's headquartered out of Denmark. We have most of our strategic sites in Denmark, but we also have them around the world: Brazil, China, France, and the US. I represent the manufacturing operations divisions, meaning the place we call the product supply, the guys that are delivering the product to the patients. And that's where my case will evolve today. It's all about getting the data from our manufacturing environments into the hands of the magicians of machine learning or the data scientists. I will say that we, like many other pharma companies, we have a digital ambition that want to increase our quality, of course, of the product. We want to instant release product. We want to increase the yield. We want to decrease the cost of our products also to give a better product for the patients. There's a little slide of the cost that also relates to closing and touchless production in our aseptic production areas. It relates to the Annex 1 areas that are so much hype right now in the pharmaceutical industry. I will today focus on the shop floor empowerment with real-time data to increase the yield and the architectures we have to build around that one. Our dream is still the same as it was 5 years ago when we really started the machine learning journey or the AI journey in our company. It has not changed. We still want to be able to have a library of digital product that we can scale quickly in years. Remember the hype cycle from the first slide? We have probably spent the last 1, 2, 3 years trying to deal with the inflated expectations and rebuilding and retooling and getting up ready to plateau in a couple of years and really get and reap the benefits of machine learning in the industry. I want to highlight that we have done a lot of successful proof of concepts. We have proven that we can increase the yield and performance with machine learning. We have proved that we can reduce the waste with machine learning. We have proved that we can lower our energy consumption with machine learning. Many POCs have been successful with doing that. We use traditional regression algorithm most of the time. We have also played a little bit with a little bit more advanced image recognition, neural networks and stuff like that. And we must say that the technology works. It's the surrounding around the technology that needs to be in place in order to really get up and get global harmonized, contextualized data to build the better AI models on. To have the data governed and trusted is another one. And then at the end, we'll get this global library of digital product that can scale faster across our network. So the pain and the situation where we work, and I have a quote here from one of my executives. He said, "Kasper, we have a graveyard of successful POCs, and we really want to scale this. We really want to bring it out to the commercial areas faster. But initially, we thought we can just add more resources, so we hired more people. Still didn't really scale. More successful POCs came along. They also failed in the scaling phase. So about 2 years ago, people really sat down and said, okay, how do we really change this? We have to retool. We need a new approach to be able to scale our machine learning capabilities. And now I want to go into some of that. But before I dive into that, remember, providing data context will give the best machine learning algorithms. So we needed to find a way to do that also. In order to understand the setup and the reason for defining a new architecture, you have to look at the value chain of how you do manufacturing intelligence. How do you bring data from the data sources out to the customers? And in my point here, the customers are the ones that want to do the machine learning models and the ones that want to look at data real time or historically to do the training or to do real time trending online. So it's a traditional setup we're looking at here. It's collecting data, it's storing data, it's finding, combining, cleaning data, and it's using the data in some kind of MI tooling. Remember, when I say manufacturing intelligence or MI tooling, it's where we do the machine learning stuff inside our manufacturing division. That's bundled into that. We have more than machine learning, that we also have just classic statistics. We have a simple visualization of trends. But all of that is part of our manufacturing intelligence strategy. So when we look at this, how do we get the data from the sources to the consumers in the right way? We found like 3 different ways of doing it. There's the tooling where it's a more ad hoc analytics, where people are normally just a data scientists looking at small data sets, small amounts of data. They can find them and play around with them, and they can kind of prove, here's an idea for a use case we have to implement and create a digital product for. But we very quickly move into what we call the multi-purpose tooling. That's where we see still a lot of data scientists, but we also start to see the manufacturing, especially the more exploratory mindset of manufacturing people think, I want to test this out. I want to see what happens if this trend is shown versus this trend of this parameter over here. That's where we move into the Tableau, the Grafana, the QuickSights, and the Power BIs of the world. It's also in that area where we start to see a higher need for harmonized data and contextualized data so that it can be reused. The third option we saw here was really the single purpose tooling. So these are the specialized digital products that we can put out on the shop floor to show the operators or the people that operate and manage the lines the data they need in order to make the smartest decision to increase yield, quality, low energy consumption, whatever it was. Those are the tools that you will, in our environment, typically see hanging on large monitors above the manufacturing lines. When we started to analyze the way data was flowing into these 3 types of tooling, MI tooling, we found out that it was very much, and now there's going to be a lot of noise on the slide, we find out that people was just point-to-point interfacing all these systems and all these solutions. And we call those the local hacks, because we couldn't really figure out where they were. And if somebody one day stopped a local hack from running, the data that came into the solution just stopped, and people were asking, where did the data stop? Why did it do that? So one of the things we found out very early was we had to create a pathway that is just taking all data through the same data path and pushing it into the same environment, harmonizing, adding context to it before we start shipping it out to our enterprise data lake and also other consumers. So what we've done is we kept all the toolings out there at the end for the end users, but we have changed the data collection and the storage principles. And that's where the Amazon Web Services comes into play. So what does the architecture look like, the one we ended up with or the one we are aiming at right now? First of all, it was not something that just came out of the sky falling down into our laps. We spent quite amount of time debating with all the requirements for the architecture coming in, and some of the requirements I want to list here. That's like, we needed to scale fast, so we needed a way to make sure that the data that comes from our data sources, they can get both to our data lake quickly, but they can also get to end users in low latency, sub-second methods. We had a need to harmonize our data, contextualize and structure them before adding them to either the end user consumer or to the data lake. And we also needed, as I said, provide this low latency data, same structure. The fourth design requirement we had was that we have a lot of legacy systems, and they're sitting down in that orange box at the bottom here. That's the legacy. So what you can say is that we pretty much took the Purdue model of the ISA S95 architecture for applications, and we augmented it with our MI tooling. What I want to highlight on this one is that the blue box here is what I'm going to talk a lot about today, because that's our harmonization layer. That's where we built the Swiss Army knife. Basically, it should be capable of taking any any data in from any of our data sources out in our manufacturing environment, convert it, harmonize it into the format we want, add metadata, move it into our data lake, which is an Amazon S3 store, and also provide the data either through an API gateway or to the end consumer in a low latency public subscribed service. With that said, how does that look in real world for us? I just one comment here is that we want to move all the data into the data lake in a JSON format. We have requirements for connecting data as OPC UA or REST services. We do know that we have a legacy of systems and application that does not support that, but we're trying to push it. But we're building up a library of drivers that can connect to all of these data sources, deliver the data, so we can harmonize it in our cloud environment. So what does those harmonized data pipelines look like inside the harmonization layer? So now we're going to zoom into that blue box in the middle. What we ended up doing is that based on the Amazon tool stack, we built two major pipelines. We built a pipeline for what we call the manufacturing operation data. That's data coming from the traditional SQL systems of the world, the LIMSs, the MESs, and the pharma industry. We moved that in through an Amazon service called the Database Migration Service. We replicate the data into our own database cluster. And then we start to do some metadata enrichment on it and basically harmonize it to fit into our data model. And I'll come back to the data model in a second. The other pipeline is the more traditional controls data. So that comes from our PLC environments, our QC instruments, the SCADAs, the historians of the world. Here we have the use of the Ignition software that is working closely together with Amazon also to provide a driver that shoots the data into a kinetic stream, and then further into some analytics. And then we again apply that into a metadata database so we can contextualize the data points with our metadata. Both of these pipelines, they supply both data through a mechanism, or again, a kinetic fire hose service into our data lake in Novo Nordisk. It's a global data lake. It's not just for manufacturing, it's for everybody in Novo Nordisk. That's based on the S3 technologies. And if you're a data scientist, most of this you will access through the Redshift cluster we have up running so that it looks like SQL data to you. That we have found the fastest and easiest way to get to the data scientists. Another pathway here is if you're not looking at historical data, but you just want to look at the real-time data, think of this as the dashboard you have in your car where you look at how many miles per hour you're driving right now, but it doesn't really matter what you drove 10 days ago. That's your historical information that your scientists need to do and train your machine learning models. But how fast you're driving right now is where you want to evaluate your machine learning model in the real-time environment. So our aim for the harmonization layer was to both deliver data in a harmonized, contextualized way to the data lake and give the same data set, the same format of those data into the real-time consumption customers. And they can be any dashboard, any other solution, whatever we are. We're providing data to other Amazon accounts, of course, Novo Nordisk Amazon accounts. We even provide data to Azure Event Hubs. We provide data in the future, maybe even to some open source Kafka streams here. We don't care. You subscribe and you get your data. Good. So that was the architecture for how we get data into the hands of our machine learning magicians or the data scientists. To do that, we also found out that one thing is technology, that's 50% of it. The other thing is harmonizing the data and structure the data the right way. To do that, we are applying the FAIR principles for data. For us, that means that you're findable. You build a data catalog, people can see and they can find the data they would like to investigate or use for their scientific explorations. They have to be accessible, meaning that when you find your data in your catalog or in our catalog, with the right access rights, you can get them into the editor of your choice. So you don't need any funky editor that nobody else is using. You have it via ODBC, JDBC, whatever other Amazon programming interfaces that you want. You have your data accessible to you. Interoperable for us, that means that data needs to have a relation to somewhere. we need to record in a context where in the process did it came from, what business process did this data point belong to, and also where physically did we actually pick up this data point from, what sensor, what system delivered it. Reusability to us means that we need to make sure that we're not building too many of those red point-to-point interfaces, but when data is available in the agreed format, people can start to reuse it. It also means that I can take one digital product developed in one part of the organization, move it to another part of the organization because the data structure and the foundation form is the same. That's a very, very important key in our ability to deliver these digital products faster to our organization. Along with these principles, it comes a little bit of governance, and I hate that I have to talk about governance also, but we had to really set up some organizational governance organs to make sure that the data was kept intact and governed. For that, we have, and I'll come back to some of the examples, we have developed approximately 10, maybe 11 data domains, each with an owner and an organization that maintain a data domain. Underneath the data domains, you will find the assets. I have an example in a minute of what that could be. An asset will have an owner again, and there will be stewards and data maintainers in a team of assets that maintain them and make sure that the structure is kept intact. With that come new roles in the organization. I'm not talking about new people, but roles for people already existing. You have, for instance, the domain owner of data. You have a category and an asset or a data asset owner sitting down here. All roles that was not there before, but we are out there applying them to existing people in our organization. We have taken the decision in our organization to align data with our business processes. Meaning, if you are the business process owner of a fermentation process or a filling or freeze-dry process, you also own the data definitions of that process. And so you become a manager of the data structure. Okay, so that's enough for the governance of it. Of course, there's a committee that oversees that the governance is put in place and all the procedures are there. Very, very traditional pharma stuff. So what does it look like for us, this FAIR model in everyday life? Remember I talked about domains. We call them the level 1 data types. Here are 3 examples. It could be the planning and production data domain, facilities and environment domain, quality and compliance domain. Every domain has from 1 to 8 subcategories, data assets in level 2. Again, every asset has certain entity types on level 3. I want to say that the 3 levels here, the 3 first levels, are just navigation. I mean, and naming. We could call them anything here. It's really just for navigation. The real magic happens down on level 4. That's where you actually get to assigning the attributes value to your entities of data you've collected. And this is where you have to be very meticulous about adding the metadata. And I have to say that there's probably more metadata out there than there's data values out there. For us, it was very important that every time we collect a data point, we also know exactly what metadata was surrounding it. So where did it came from in the physical world? What business process did it belong to? Is there any retention time of this data set? Is there the classic one, of course, the unit of measure description? The business logic, is this an aggregated? Is this a rolling 7-day average we're getting? All of that. And then, of course, the value. And we had a definition of what a value could be like. There's the traditional, just continuous values. There could be complex values built up of more complex structures. But all in all, we have an idea that we will end up with 2 million physical instances of our data points. So that will be an equivalent to maybe 2 million IoT sensors out there. Along with this data modeling work, and this takes time, because I have to say that we initially thought, oh, we can just find a data model out there. Somebody must have done something like this before in our industry. Yes, you can find the bits and pieces. There's not one model that you can just take and it maps it into your company. There's all these small differences in all these companies. So we actually took an outset in the ISA 95 model for manufacturing. And then build on that one. We don't follow it strictly, but we took an outset in that, and then we map it into some of our high-level data domains. Good. Starting on this journey, when you start to come out into your manufacturing areas where you have to start connecting data, you also have to think about a different skill set for those people. And I want to touch a little bit on that one. So the competences that people have on our manufacturing floors was not, I mean, we wanted to use the data, and we had a couple of very royal persons that knew exactly what they wanted to do. But when we hit the shop floor, I really love these quotes here that I collected during some interviews out there. So, yes, they all know that we should work with data. There is a desire out there to establish all of this. But the knowledge and the ability to actually go apply the value is not there right now. So when we come out to sites, we often found these quotes here saying, I just don't have the time. How can I enable 5,000 data points and I have 1 hour a day to do this on top of my other job? So there's a little bit of education here. Maybe you should scale down on some of the activities they do now and then start educating them into this. I have to say the two areas we have found most valuable in teaching the people on the shop floor and the line managers out there is like, how do you link your business problem to your digital product? Because that's where all the use cases and ideas come from. So if you can give me, this is my business problem, how can you link that into a new product and then understand what data you need to transform into having a good digital product? So the skill to link business problem to digital product is needed. It's not just a UI expert, it's more than that. The other one was that we need for people to understand that when you're dealing with manufacturing equipment, automation, OT equipment, or IoT, you need the knowledge of how do those protocols down there function? What are the data formats that comes out of them? How can I translate that into a business problem, those formats? So it's understanding how the data is generated on the shop floor, contextualizing it, and then moving it into the global storage. Just so you know that you can't enable 5,000 tags in one day, but because you have to spend time contextualizing it first. So that was a little bit about the competences and the talent challenge that we saw. Now, back to the dream and the end, because we honestly believe that we have achieved what we wanted. We can today, with the first cases, see that we can scale our digital product, and I have some examples of that in a second. We can scale in weeks, not years, maybe not years, but at least we can scale in way faster than we did before, meaning that if there's a good digital solution that gives us a good performance yield or good increase in performance, reduces some waste somewhere, we can deploy it to other similar manufacturing lines in weeks because we have the foundation for data. Alongside that, we are now starting to see our global library of digital products to build up. Not that full, but eventually there will be a lot of those digital products. So when one guy comes in from one part of the network and say, I have this business problem, you might be able to say, well, we have a library of digital products, apply this one. It's built in with machine learning and AI or whatever is needed to solve this business problem. And those library elements, they're kept as configuration items on our shelves. But to get there, we needed to put that governance in place so that people can trust the data. And we also needed to find out the mechanisms to harmonize the data and contextualize the data prior to giving it to the machine learning magicians. All in all, I believe that we are on the right track here. But it took us a couple of years to realize that it was a retooling of the architectures and some governance setup and organizational change management that was needed. Just some examples of our digital products. I don't want to go into the details of them, but this is what it could look like. I had to put some orange boxes on some of the numbers due to intellectual properties. But eventually we'll end up with a chessboard of these digital products that we can quickly scale out to our existing network. That was all for me. If you want to contact me later, use my email, or I also have a profile on LinkedIn if needed. Thank you very much and enjoy the rest of your day.